When you think about recycling a plastic bottle, you might imagine a simple, straightforward process. You toss it in the bin and it magically reappears on a store shelf. But the reality is far more complex. It's a journey of technology, logistics, economics, and environmental science. Today, we're going to explore that journey, looking at what actually happens when you recycle PET bottles, guided by some of the most detailed research on the topic. We'll discuss different types of recycling, the key role that product design and collection systems play, and the tangible environmental benefits, all from the perspective of life cycle assessments and circular economy principles.
Process begins, of course, with collection and sorting. After you place a PET bottle in your recycling bin, it's sent to a material recovery facility. Here, sophisticated machinery and human sorters work together to separate the different types of plastics, glass, and paper. This separation is crucial for ensuring the quality of the recycled material. For example, clear PET bottles are more valuable than colored ones because they can be recycled into a wider range of products without affecting the color. Once the PET bottles are isolated, they go through a rigorous cleaning and shredding process. They are washed to remove any labels, caps, and leftover residues, then shredded into small pieces called flakes. At this stage, it's critical to ensure the flakes are as pure as possible. Contamination with other plastics, even in small amounts, can severely degrade the quality of the final product. For instance, a small amount of PVC in a PET recycling stream can lead to the release of hydrochloric acid gas when melted, which degrades the PET resin. After cleaning, the flakes are ready for the next phase, which can take one of the two main routes: mechanical or chemical recycling.
Mechanical recycling is the most common and involves a melt and reform process. The clean PET flakes are melted down and extruded into new pellets. This method is highly energy efficient and has a low environmental impact compared to making virgin plastic. However, the process can cause the polymer chains to shorten, which reduces the strength and quality of the plastic. This leads to the concept of downcycling or open loop recycling. This is when a material is recycled into a product of lower quality or value. For example, a PET bottle might be mechanically recycled into polyester fiber for clothing or carpets. While still a positive step, avoiding landfills, this process often doesn't allow the material to be recycled again after its second life, as the quality has degraded too much. The LCA studied in the provided source indicates that open loop recycling of PET bottles into polyester fiber saves between 45% and 85% of non-renewable energy compared to the producing virgin polyester. The alternative is chemical recycling, sometimes called feedstock recycling. This advanced process breaks down the PET polymer to its original chemical components or monomers. These monomers are purified and then repolymerized to create a new PET resin that is indistinguishable from virgin plastic. This is the key to closed-loop recycling, where a bottle can be recycled back into a new bottle of the same quality, which can then be recycled again and again. While chemical recycling is more expensive and energy-intensive than mechanical recycling, it offers a pathway to true material circularity. This method is still advancing but has been more successful for PET than for other plastics.
Why is all of this worth it? The answer lies in the concept of life cycle assessment, or LCA. An LCA analyzes a product's environmental impact from cradle to grave, from raw material extraction to final disposal. When comparing recycled PET to virgin PET, the benefits are clear. LCA studies show that recycling reduces the consumption of fossil fuels, as virgin plastic production uses about 4% of the world's oil and gas for feedstock and another 3 to 4% for manufacturing energy. A study on PET bottle recycling found a net benefit of about 1.5 tons of CO2 equivalents mitigated for every ton of recycled PET. Another LCA specifically on bottle-to-bottle recycling found that a bottle made with 100% recycled content could reduce its full life cycle emissions by 27% compared to a bottle made from 100% virgin material. The core benefit comes from the substitution of virgin polymer production. The sustainability of the recycling system is not just about the plastic itself, it's about the entire ecosystem it supports. This includes the social and economic aspects. For instance, in developing countries, informal waste collectors or scavengers play a critical role in the collection process. Business models like PetStar in Mexico have demonstrated how to create an inclusive collection system that formalizes the work of these collectors, providing them with a stable income and contributing to the social value of the recycling process. This creates a system that is not only economically viable and environmentally sound, but also socially responsible. In conclusion, the recycling of a single PET bottle is a small part of a much larger and more impactful system. While challenges remain, especially in collection, sorting, and ensuring a market for recycled materials, the continuous advancements in technology and policy are making a true circular economy for plastics an increasingly achievable goal. When you recycle a bottle, you're not just diverting waste, you're participating in a dynamic system that conserves resources, reduces pollution, and builds a more sustainable future.